Here we can see a bowling ball and several feathers about to be dropped, demonstrating one of science's great questions. Do heavier objects fall faster than lighter objects? What if I were to tell you that they fall at the exact same rate? Would you believe me? Well, maybe not. Let's watch this video of the experiment conducted by Professor Brian Cox at NASA's Space Power Facility near Cleveland, Ohio. Okay, to be fair, just because they reach the ground at different times does not mean they fall at different rates. So, why would a feather and a bowling ball drop at the same speed? To explain this, let's go back in time. Around 400 years ago, an Italian scientist named Galileo Galilei conducted an experiment where he dropped cannonballs, musket balls, gold, silver, and wood off of the Leaning Tower of Pisa. Galileo discovered that all of the objects hit the ground at the same time, thus proving that gravity accelerates all objects at the same rate. Today, scientists call this principle the universality of freefall, or the equivalence principle. Fast forward about a century, Sir Isaac Newton, an English scientist, made groundbreaking discoveries about gravity. He broke part of his discoveries down into 3 laws, the first of which being the most important to this experiment. Newton's first law was the principle of inertia, or the idea that every object will stay in motion or at rest unless it is changed by a force acting on it. To explain this, let's go back to Galileo's experiment with dropping objects off of the Leaning Tower of Pisa. If Galileo were to drop an object, let's say a cannonball, off of the tower, it would keep falling forever unless there was something to stop it, like the ground. Newton would say, in the present-day version of the experiment, that the bowling ball and the feathers fall because of the gravitational force pulling them down. Let's fast forward again a couple of centuries. Albert Einstein was a German scientist who put forward his world-renowned special theory of relativity. The theory argues that if the bowling ball and feathers were put in a chamber with no air, also called a vacuum, then they would not be falling, but rather standing still. In an environment where air is present, the bowling ball is going to hit the ground faster than the feathers because the feathers have more air resistance. In a vacuum, we can see that the bowling ball and the feathers hit the ground at the same time. The rationale for this is that if one were to remove the background, one would not be able to tell if the objects are moving or not, so Einstein concluded that they aren't. This principle can also be seen in a demonstration done by Commander David Scott on the Apollo 15 mission in 1971. Here we can see Commander Scott on the moon, where there is no air and hence no air resistance, drop a hammer and a feather at the same time. Let's watch what happens.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
Light objects only accelerate for a certain amount of time before the force of them going down is counteracted by air resistance, at which point the object reaches its terminal velocity, or the velocity at which a falling body moves through a medium when the force of resistance of the medium is equal in magnitude and opposite in direction to the force of gravity. Put in more simple terms, the steady speed an object reaches after its acceleration was counteracted by gravity. So, technically, in our everyday environment, a bowling ball would hit the ground faster than the feathers. But this is only because of air resistance. If we could remove the air, we would see that the objects fall at the same rate.